Is there water in the universe? Is there water elsewhere in the solar system than on Earth? Where does the water on Earth come from? Has it been there since the formation of our planet, or did it come afterwards? These questions have been intriguing scientists for a long time. Astronomers and astrophysicists who search the heavens with their ever more powerful instruments, building theories to try to understand and explain the origins and evolution of the universe. Geologists who study rocks of all sorts, terrestrial or extraterrestrial. But how did it all start? In the beginning, there was nothing. And then it's the Big Bang, forming space and time. With the Big Bang, the first element is forged, hydrogen, the lightest and simplest. It is everywhere. From large hydrogen clouds, the first stars are born. The largest and heaviest are short-lived. They transform their hydrogen into heavier atoms. When they die, they free those elements into space. From this material, new stars are born. They forge even heavier elements in their centers, releasing them into space at the end of their lives. And so all the necessary elements are available to form small grains of silicates. It is at the surface of these grains that hydrogen and oxygen combine to form water. Water is a very special and abundant molecule in the universe, and that is not a surprise. Indeed, hydrogen being the most abundant element, and oxygen being the third most abundant one, it is not surprising to find water everywhere in the universe. The water molecule has a very special configuration, being composed of 2 hydrogen atoms and 1 oxygen atom. The negative electric charges are shifted relative to the positive charges, resulting in an electrical dipole. This gives surprising chemical properties to water. Water is a great solvent. Its role in many processes and chemical reactions is fundamental. Water played an important role in the formation of planets in the solar system, because of its line of condensation, which marked the difference between terrestrial planets on the one hand and giant gas planets on the other hand. Water also played an important role in the formation and evolution of the terrestrial planets, which evolved differently from very similar initial conditions. Water tells us the divergent stories of the planets Mars, Venus, and Earth. Water intervenes in a multitude of chemical reactions, and life as we know it could not possibly exist without it. Water is everywhere in the universe, and in our daily lives, from the moment we get up to the moment we go to sleep. "70% of the mass of our bodies is water. It is thus very precious for us, human beings, directly relating with our health and lives. We find water everywhere in the universe, in galaxies, in the interstellar medium, in the atmosphere of certain stars, and around stars in formation. We find it everywhere in the solar system. On Earth, of course, and in the form of ice in craters at the poles of the Moon or Mercury. Water is present in the polar caps on Mars, and it definitely ran in liquid form at the surface of the red planet in a distant past. It constitutes up to 10% of the mass of asteroids. We find it in the satellites of the giant planets, forming true oceans beneath the ice layers, or being thrown out by active volcanoes. We find it in comets, those blocks of ice that come from the edges of the solar system and evaporate near the Sun. It is also present in extrasolar stellar systems. Water in the universe appears essentially in gaseous form or in ice form. Only on Earth do we see it in liquid form. We can detect it using spectroscopy, which means splitting the light into colors to produce a spectrum. These colors are not visible because they are at infrared wavelengths. The water spectrum has a particular sequence of emission and absorption bands, thus revealing its presence without ambiguity. Observing celestial objects with telescopes, astronomers are able to detect the presence of water and determine its state and quantity. Thus have we learned that in the universe, water presents itself mainly in gaseous form. Closer to us in our solar system, water is everywhere. We find it in the atmospheres of the giant planets, as well as in the atmospheres of Mars, Venus, and Earth. Concerning the terrestrial planets, water played a critical role in their evolution. For example, understanding the history of water in Venus on Mars helps us to understand the evolution of these planets. The D/H ratio is an important parameter in these studies. D is deuterium, the isotope of hydrogen. It is the hydrogen atom with an additional neutron in its nucleus. Compared to the terrestrial value, the D/H ratio is enriched by a factor of 5 on Mars and 120 on Venus. Venus is warmer than Earth due to its proximity to the Sun. Water was as abundant on Venus as on Earth, but because of the temperature, it evaporated much more. Water vapor in the atmosphere is destroyed by ultraviolet radiation, dissociating in oxygen, hydrogen, and in the case of heavy water, deuterium atoms. Deuterium, being twice as heavy as hydrogen, does not escape as readily. As a consequence of this differential escape, the D/H ratio on Venus increased until today's value of 120 times the terrestrial value. In the case of Mars, the D/H ratio also suggests differential escape, implying that the atmosphere of Mars was once much denser, perhaps as dense as the Earth's today, which might have made possible the existence of life. Images of the red planet taken by spacecraft show highly developed fluvial networks, indicating this to be a plausible hypothesis. Therefore, the cycle of water played and still plays a major role in the climate evolution of Mars. Talking of liquid water is the same as talking of the possible existence of life. The big goal of the future space missions to Mars is to look for traces of past or present life. We find water in ice form on almost all the moons of the giant planets. There is strong evidence to believe that on Europa, a moon of Jupiter, an ocean of liquid water under the ice crust exists. A future mission to Europa may confirm this. Water is also present on small bodies, being about 10% of the mass of asteroids and 90% of the mass of comets. These small bodies have probably played an important role in the formation and evolution of our planet, bringing a large part of the water contained currently in the terrestrial oceans. Our planet is a unique place, as we find water in all states, gas, solid and liquid. Water passes from one state to another in the famous water cycle. Water covers about 70% of the surface of the planet. We have yet to discover another object in the universe with liquid water on the surface. Thanks to the distance to the Sun and the greenhouse effect, which maintains the temperature at the surface above 0 degrees Celsius, life has developed on Earth, meaning that we are well into the habitable zone of our star, the Sun. Water is also the most refractory of species, which means that it sublimates at the highest temperature. When we move away from the Sun towards the outer planets, water is the first molecule to condense. It defines the so-called condensation line, or ice line, beyond which all matter, except hydrogen and helium, condenses. Right after the collapse of the protosolar nebula, the heliocentric distance of the ice line was about 4 to 5 astronomical units. The ice line marks a boundary in the quantity of matter available for planet accretion. Therefore, inwards of this boundary, only small planets could form with at most the size of the Earth. Beyond the ice line, giant planets were able to grow and grow, absorbing even hydrogen gas, the main constituent of the protosolar disk. Water is a very special and very abundant molecule in the universe. We find it everywhere, in galaxies, nebulae, stars, the solar system, and of course, on Earth. Water exists in all forms, liquid, gaseous and solid. On Earth it is mainly present in liquid form, making life possible on our planet. Without it, life as we know it could not exist. Planets around other stars are being discovered every day. Scientists search for these planets in the habitable zones of the host stars, zones where liquid water may be present. To search for water and to understand it is to understand our origins. It is all about finding life.